Welcome back to another MS Tutorial video. Today we'll be covering Form 4 Chapter 5, Progressions.
Alright, so for progressions, we're going to be looking into two things. First, we're going to be looking into arithmetic progressions, and then we're going to be looking into geometric progressions. So I like to give them a little short form, a little nickname. I call them EPGP. Alright, so arithmetic progressions. So let's say you've been given this progression, 1, 5, 9, and then it keeps going on. So we would usually call these numbers terms. So let's say, for example, I'm going to label this as a term. So 1 would be term 1, whereas 5 would be term 2, and 9 would be term 3, and it goes on, so on and so forth. Now, if I were to say this was a sequence, in sequence form, I would label this as A plus D, and then A plus 2D, and so on and so forth. So if I was, say, looking for the fourth term, it would be A plus 3D. Alright, so you must be wondering, what is A and D, right? So basically, A is the first term, whereas D is the common difference. So as we can see here, our first term would be 1, and the way we find our common difference is that D will equal to term n minus term n minus 1. That means we would have to take the term after, subtract it with the term before. So let's say I wanted to find the common difference of this progression. I could take a term 2 minus term 1, which is the same thing as 5 minus 1. Therefore, our common difference would be 4. If, let's say, our progression was actually decreasing, so it's getting into a negative number, your common difference will usually be a negative number because it would be subtracting. Now then, the next thing we need to know, basically arithmetic progressions has a few formulas that we need to know. The first one being how to find a specific term, so term n. That would be term n equals to A plus n minus 1 times D. Alright, so let's say I wanted to find the third term, right? T3. I would have to write 1 plus 3 minus 1, and we know our common difference is 4. So it would be the same thing as 1 plus 8 and it equals to 9. So if we check back, our term 3 is 9. Same thing. So now let's look into the second formula. Now, sometimes some questions will actually ask for the sum of progressions until a specific term. So this is usually labeled as Sn, S being sum. So the formula is actually Sn equals to n over 2 times 2a plus n minus 1d. Alright, or it can also be written as n over 2 a plus l, where l is the last term. Alright, so I'll show you how to use this. Basically, let's say I wanted to find the sum until term 3, alright, S3. So I would actually have to write, let's just sub back in the values. So n we know is 3 over 2, 2a, a will be 1 plus 3 minus 1, common difference is 4. So if I were to multiply all this, I'll get 2, 8 plus 2, 10, it would be 15. So let's check that real quick. 1 plus 5 plus 9 is also 15. So we can mark this as correct. Now then, how would you want to use the other equation, which is n over 2a plus l, right? So for this one, l has to be the last number. So in this case, we know that our last number, which is the third term, is 9. So we could also write this as n over 2, so it would be 3 over 2 times 1 plus 9. So then I would get the same thing, 10 times 3 over 2 will be 15. So this is usually useful when they don't give you the full sequence, but they give you the last number of that sequence. Alright, so now we're going to be looking into geometric progressions. So, just like arithmetic progressions, the terms are the same, right? T1, T2, T3. But what's different is the sequence, actually. So instead of a plus d, a plus 2d, all right, instead of adding or subtracting, you're actually multiplying. So in this case, it would be ar squared, ar cubed. Same for both sequences on the left and right, all right? It's always going to be ar squared, ar cubed, things like that. Now, you must be wondering, what is r, right? So r, or better known as common ratio. So this is much different compared to common difference, where common difference is where you add or you subtract, right? It's going to be a positive or negative value. But for geometric progressions, common ratio is being multiplied or divided. So how do you find it? You use the formula term n over term n minus 1. So this is the same thing as arithmetic progressions, where they do like term 2 minus term 1. But in this case, it's like term 2 divided by term 1, alright? So let's say I want to find the common ratio for the first sequence on the left here. So it would be the same thing as 4 over 2, so I would get 2. Whereas the sequence on the left will have the common ratio of 8 over 16, or also better known as 1 over 2. So that means if we look at both of these sequences, we can see that the left one is when the terms keep increasing, they keep being multiplied by 2. Whereas for the second sequence, when the term keeps increasing, the term is actually being divided by 2 consistently, alright? So now then, we need to know some of the formulas. So the first one would be to find a specific term, right? So term n equals to a times rn minus 1, alright? So let's say I want to find term 6 of our first sequence on the left here. Term 6 would be the same thing as 2 times 2 to the power of 6 minus 1. So it's the same thing as 2 times 2 to the power of 5, 2 times 32, you get 64. Just like that, easy. Now the next one is to find the sum of the terms, right? But unlike AP, arithmetic progressions, they actually have 2 different sum of terms formulas. So the first one is when r is greater than 1 and when r is less than 1. So 1 is when r is being multiplied, 1 is when r is being divided, alright? So when r is greater than 1, our formula will be Sn equals to a times r to the power of n minus 1 over r minus 1, alright? Whereas our second formula for when r is less than 1 is a times 1 minus r to the power of n over 1 minus r. So for me, the easiest way to remember is by looking at the placement of the r. So we already know that when r is greater than 1, r can minus 1. So we put it before 1, right? And when r is less than 1, it's going to be smaller than 1. So that means 1 can minus r. So you put it on the right, like that. So let's test it out. So let's say I'm going to use for the first sequence on the left here. So I want sum until 3, right? Sum until 3 would be the same thing as 2 times 2 to the power of 3 minus 1 over 2 minus 1. So I would get 8 minus 1, 7. 7 times 2, 14. So if we check over here, 2 plus 4 plus 8. Yep, same answer. And then common sense for the second formula, just have to sub in the values and just keep in mind of the fact that r has to be less than 1 when you use this formula. Now the last formula we're going to be looking at is when s to infinity. Now s to infinity is specifically used for when r is less than 1. That means we can't use it for the first sequence, alright? That means s for infinity for the first sequence is out of the question. You have to use it for our second sequence since r equals to 1 over 2, right? So r equals 1 over 2 is actually less than 1. So the way sum of infinity works is how basically when you keep multiplying the terms by 1 over 2, they keep becoming smaller and smaller and smaller until the numbers are like super small decimals. So when you use sum to infinity, it's almost like rounding off that infinity. It's like trying to find that the closest number, that rounded off number to a specific value of sums. So basically sum of infinity equals to a over 1 minus r. This is much easier. Same concept like sum of certain number of terms for when r is less than 1. 1 has to be in front of r. So let's say the sum of infinity for our second equation here would be the same thing as 16 over 1 minus 1 over 2. So 1 minus 1 over 2 is 1 over 2 is the same thing as 16 times 2, 32. So sum of infinity actually has multiple uses. I'll be covering that in a later video for when we answer questions together. Alright, so before I end the video, let's run over some quick tips, alright? So number 1, let's say you wanted to find term n, right? It's also the same thing as sum of n minus sum of n minus 1. So as in, let's say I wanted to find term 3, right? It's actually the same thing as term 3 minus term 2. Because if you think about it, not term 3 minus term 2. I was actually referring to S3 minus S2. Because it's actually the same thing as, like, let's say 1, 2, 3, right? So it's like the total is 6. And S2 would be 1 and 2, right? So it would be 3. So if we do the thinking, it's like 6 minus 3. Like logically, like basically 1, 2, 3, and then this is 1, 2. Basically, you'd be left with the 3. So term 3 would be 3. Just like that. Some questions actually, I wouldn't say use this, but it could be used because sometimes they just keep throwing you sums of values, but they don't give you any terms. So this could be an easy way to find that term. Right, number 2. As we know that term 1 is equal to a, right? It's also equal to sum 1, the sum of the first term. Because if you think about it, sum of the first term is the first term. Because you're not adding it with the term of 0, right? That doesn't make sense. So that's my second tip. Just something good to know in case. Lastly, my last tip would be about geometric progressions especially. Basically, you gotta be careful with the indices part of this. Because sometimes when they ask you to find a term, to find a sum, you have to play around with indices. So basically that one's a very difficult one. It's like indices with unknowns. So you have to be careful with how you flip through it, you know. Sometimes if your value is like squared, you have to remember that it's actually square root plus minus, you know. It's not just square root. If it was cube, it would be completely fine to leave it as a positive value. But if it was square root, as in power to 2, you might have to give the positive or negative value, or both. But usually, for KSSM, we focus on the positive value, so just stick to that. Alright, and lastly, just know how to differentiate between term and sequence, because sometimes it's actually really good to write out the term and sequence when you answer a question. You can actually see the correlation between maybe multiple different terms, because sometimes they actually do that, multiple patterns. But other than that, it's actually quite simple. This is a very easy topic to me, to be honest. Just have to remember the formulas and you can actually go through it very quickly, trust me.
Thanks for watching, guys. I'll see you next time. Ciao, Lu!